So I'm just going to try and demonstrate in this video how to use some of the features that are included in the Racmacs viewer for looking at sequence data. So I have here the H3 map from 2004 loaded, and I've added sequences to it as shown in the example. And to begin with, there's no difference. So you can see here, this is just the viewer as normal. If you look here in the buttons at the top right, alongside the usual buttons, there is an additional button here, View Sequence Table. We'll come to that in a second. And if we open up the control panel here, and we go to the Colouring tab, we can see that alongside the normal options for colouring by default and stress, there's an option here for colouring by sequence. And now when you select that, nothing changes, but you can input the position that you would like to colour the strains by. So for example, if I type in position 145, we get a legend at the bottom right, and the strains are coloured accordingly, and in this case also the sera where there's sequence data available. Now the reason why it's useful to show this in a tutorial is there's some additional things that can be useful when you're looking at the data in this way. For example, so here we've coloured by position 145, and we can see that generally there's quite strong clustering antigenically by this position, which is as expected because it's one that's been identified as often having a strong antigenic effect. But there are seemingly some outliers in some of the cases, and we can use the viewer to interactively investigate some of these cases. So for example, this strain here, if we go back to default, so these are clustering in the CIS187 cluster according to the standard clustering approach. But there are two here that have a K at 145, which is characteristic of the Beijing 89 strains here, as you can see. Now, we might be interested to know why are those strains back here, and we can zoom in and look at this. And this is where first of all, the sequence viewer can come in handy. So we're going to open the sequence table here. It takes some time to load in this case. And just going to change my viewer size. So here you can see all of the sequences for each of the antigens and sera shown. If you scroll over these strains, it shows you where they are on the map. You can very simplistically enter a position up here just to see the sequences at that position. Or more usefully, you can, if you select a strain in the map, this sequence viewer will update to show you only the sequence for that strain. But in particular, if you select another strain or multiple strains, it will show you the positions where they differ in their sequence. So we can see these two, in a sense, outliers are pretty antigenically similar in this case. There's very little difference between them. Now we can compare it to this strain here, for example. And again, we can see that this strain is also very antigenically similar to the others. Differs pretty much only by the N at 145. And if we bring in some of the other strains from the CIS187 cluster, we can see here that we're starting to see some more genetic differences. I'm holding down Shift to select additional strains, or Command. If you hold down Command and you click a strain that's selected, it will deselect it for you. So we can also go in the other direction and see what their similarity is to these strains over here. And again, you can sort of see similar differences, or a similar amount of genetic difference here. And you can start to investigate the sequences that might be of interest. One question that you might want to ask is, well, what have these strains been titrated against? So is their location further back here indicative of true antigenic differences, or is it perhaps an artifact of what the sera that they've been titrated against? So if I click on the strain again to select it, when you have the focus on the viewer, and you can tell that the focus is on the viewer because you get this light blue border around it, you can see it changes from what is now grey to light blue in this case. When it has this focus, if you press the C key for connections, you can see lines drawn to the sera against which this was titrated. And if you press the T key to show titers, it will add titers onto these connection lines. So we can see, for example, that this strain has only been titrated against these sera back here. And if we click on this strain, we can see it's a similar set of sera back here that it's been titrated against. And then you can compare, so you could say, well, what about these strains that are further antigenically advanced? They've been titrated against additional sera. In most cases, these future sera, they have got less than titers, so you wouldn't expect that to be affecting the position. But there's a 20 here, 10 here, this could be affecting the position. And so already we're forming a bit of a hypothesis that these strains, although they have this, what is thought to be an antigenically important mutation of the K at 145, perhaps they're back here because they haven't been titrated against any of these later sera. And you can see, perhaps most significantly, these strains have not been titrated against any sera that has a K at 145. Whereas these, if we look at these strains here, we can see that they have. And if you click on the sera, you can similarly see, well, what have these sera been titrated against? This is showing the column basis here on the sera, and then the titers show the titers to the antigens. So you can see here that this serum, for example, has been titrated against pretty much all of these strains in the Beijing 89 cluster, but not these two. So this could be a reason, perhaps, why these strains are back here, and perhaps something that, upon investigation, you might decide that you want to add some additional titrations to correct differences like this. The final key that's useful is the E key for error lines. So that will convert connection lines to error lines, which shows how close or far the serum and antigens are from each other compared to what the titer suggests the distance should be. There's a more in-depth explanation of that in one of the tutorials. And if we press T, we can turn off titers again, and now in this case just looking at error lines. So another thing to check might be to see whether these strains look to be particularly stressed or not, and looking at the error lines, that doesn't seem to be a problem. So there you have it. There's many things that you can do with this with these tools. but I've shown you the main ones here. We can change the position that we colour by. We can investigate other positions for antigenic effects. Sometimes it's useful to toggle between default and sequence, so you can see how your typical antigenic clustering is differing. And I think I will stop there and leave that. That's just a brief example of how we can use this to dig into the genetic correlations with antigenic characteristics.